Friends, welcome to the channel. Today I am introducing series of videos for digital communication concepts, as a part of which I'll be taking a concept from prerequisite to the digital communication towards the spectrum concept. As a part of which today we will be addressing the what are all the prerequisites required for the digital communication systems to understand. Okay, as a point of which I am wishing that the people are aware about the principles of communication system concepts like modulation, what are the communication channel, what are the transmitters, receivers, and what are the what are analog modulation schemes, what are the advantages of analog and advantages of digital modulation schemes over the analog modulation scheme. So all such points I think that people are aware about. So accordingly, I would like to go for I would like to take some of the key points to make digital communication to understand very easily. Okay, as a part of which a person who is wish to understand digital communication properly, he has to distinguish the analog and digital signal and its related spectrum. This is the first basic point is required while I start to understand the digital communication. Okay, after that, what is the fundamental concept of modulation? Okay, we have gone through the communication modulation schemes like AM, FM, analog modulation schemes, right? So those at the time, what is the fundamental rule of that need for modulation, you can say, right? What are the need for modulation we supposed to be clear about. And here for the sampling and reconstruction is to be considered. As we people are already aware about that the sampling concepts are usually happens at the transmitter end, right? But actually it will even happen at the receiver end while we people are reconstructing the digital data at the receiver. So that's what once again sampling and reconstruction we supposed to recall. Okay, and coming to the advantages and disadvantages. So coming to advantages and disadvantages, I think people are aware about what are all the digital communication advantages over the analog communication. It's very simple, like it is allowing us to enjoy the multiplexing, noise immunity, and also encoding schemes, channel encoding, source encoding. All these things are possible because the only when the data is in the form of or incoming signal is in the form of digital. So that is what we supposed to aware like before we design the digital communication system. And coming to the next point, like multiplexing technique. Actually, in case of a fundamental communication system, we were aware about how to do the time division multiplexing, but in case of digital communication, we may be understanding the concept of orthogonal frequency division multiplexing like that. So for that reasons, we should know the concept of time division multiplexing, how it can be implemented over the frequency division multiplexing and orthogonal frequency division multiplexing. All those concepts we supposed to carry from the principles of communication system. Already we were aware about some of the synchronization techniques like bit synchronization, carrier synchronization. No doubt in case of digital communication also we need a carrier synchronization because coherent receiver we would like to design. So these are all the points, right? So coming to a random occurrence of an event. Okay, if we would like to take a particular value, if we would like to take like at a particular time, what will be the random occurrence of an event? So that is defined by the random variables. Okay, so you may be aware about it. What exactly random variable is? It is a random occurrence of an event at a particular time instant. Okay, so that is actually we people are analyzing for the occurrences of noise, distortion, like that. Okay, so in case of a wireless channels, we have come across random variables because we are having atmospheric noise, we are having channel distortions, all those things. So that's what the random variables we supposed to understand. Actually, all those events are not occurring with respect to a particular time. Actually, all those random events are occurring continuously. Okay, that's what the concept of random process we supposed to understand. So that is a part of digital communication, so we will understand. Okay, coming to the next, probability. Actually, after on having the digital communication, there is a need of information theory to understand. At that time there is a many calculations like entropy, channel capacity, and all those things are coming into picture. So in order to understand them, probability is very must. Okay, and other than that, even for getting the probability of error, okay, even for getting the probability of error of a channel or a particular modulation scheme like BPSK, QPSK, MSK, all those things. So to calculate the probability of error also we need the probability concept, no doubt. So we will understand that once again. So frequency spreading concept. Okay, actually for this point I would like to explain by using one diagram, because we supposed to make clear about what is frequency translation and frequency spreading. Okay, just a minute, I will be taking a pen to make you to clear about this. See, frequency translation means shifting the frequency. Okay, frequency spreading means what? I'm completely spreading my available frequency into means small frequency, I am spreading it into larger frequency. Are you understanding? Frequency spreading means for a particular signal, let us consider this is a frequency spectrum. Okay, right? So frequency spreading, if I do, it will go like this. Okay, so you may ask like what are all the advantage why we supposed to make such frequency into like this spreaded frequency. It's very simple, like we will get the advantage of security, we will get the advantage of even jamming concept and lower probability of interception. All these are the very crucial communication needs. Okay, security, noise immunity, jamming, and lower probability of interception, they have their own importance. So that's what we supposed to understand. So now I'll be drawing one diagram how to do the frequency spreading. It's very simple. You will have a one data, digital data like this. Okay, so this is of very long bit duration. You see, this is of very long bit duration. So this long bit duration data you would like to spread on using very short duration data like this. Zeros and ones are very short here. So as of which the spectrum of this signal will get spread as per this signal. Okay, because the frequency of this signal is more. Frequency of this signal is very much high compared to frequency of this signal. So as a part of which there is a spreading of the spectrum happens. So this spreading of spectrum will give me a large set of advantages like jamming, noise immunity, all those things. Okay, so now I will be removing the I will be taking a pointer. Okay, so shall I proceed? So I feel like we can move forward. So now analog communication to digital communication, what are all the gaps we have found? So it's very simple. I already told that from the TDM we are moving towards a OFDM. Okay, so before that we supposed to understand what is FDM. Okay, frequency division multiplexing. I think you were aware about time division of multiplexing, how it happens. Okay, in case of a frequency division multiplexing, each user is allotted with a different frequency. Each user is allotted with different frequency. He will be using that particular frequency to communicate it to other receiver or to communicate it to other world. So here the frequency is being divided. Okay, in case of TDM, time is being divided between different users. Here the frequency is available frequency is divided among different users. Okay, so advanced version of this FDM is only your orthogonal frequency division multiplexing, wherein there is no collision of two different frequencies. Okay, all the frequencies are orthogonal to each other, so there will not be any interference happens between them. So that's the advantages of OFDM. Okay, so then we will have another one important thing like digital data modulation schemes. Actually what happened, in case of our analog modulation schemes like AM and FM, we have not concentrated more about PM, right? So here actually PM is playing very important role compared to both amplitude based modulation and frequency based modulation. Phase based modulation is playing very important role. Let us observe how they are all different, and how PSK is important and how phase modulations are important. Okay, before I start that, we will try to understand what is shift keying. Okay, so dear students, like today what are the data? what are the input signal we are having for digital communication? What are the input signals we are having for digital communication? It's very simple. The input signal is digital in nature, right? In analog communication, the input signal is analog in nature. So as of which, if the data is in digital in nature, due to the property of binary, because digital signals are having the binary concept in mind or binary properties, okay, because here the binary things will have logic 0, logic 1 like that. So that logic I'll be taking like a plus 5 volt and 0. Logic 1 is represented by plus 5 volt and logic 0 is represented by 0 volt. So that's what, there are only two possible input, right? Input signal. What are those? 0 and 1 or 5 volt and 0 volt. Okay, because of that reason shift keying concept is coming into picture, because I am doing digital communication means only two digits are there like 0 and 1. Okay, so as of which we are having the concept of shift keying. What is shift keying? Keying means what? Like on off, on off. Okay, so what am I doing on off here? In case of ASK, what am I doing on off here? Yes, in case of ASK I'll be doing amplitude on off, right? Amplitude on off. Okay, in case of FSK I'll be doing frequency being shifted. Okay, shift keying. Keying means on off. Frequency shift keying. In case of PSK I'll be doing phase shift keying. Okay, so we are already aware that if I use ASK there is one problem, right? What is that? Noise immunity is more. Sorry, noise means ASK signal are affected by noise because amplitude is going to change. FSK, so we can use FSK no doubt as like FM. Okay, but the problem is what? Here the shift keying is not necessary for large number of frequencies, right? Here the shift keying is not necessary for large number of keying, because my shift keying I can use for only binary, octal, hexadecimal bit. There is distinct amount of, means limited amount of shift keyings I can use. So for that, phase shift keying is very simple to use compared to frequency shift keying. Usually what happens in case of frequency shift keying or FM, we are generating different frequencies for different change in amplitude, right, for the message signal. But here the change in amplitude for FSK is very simple, either 0 or 5 volt. If it is of binary, if it is of octal or something else, so they will be of very distinct number of change in amplitudes are happening. So that I would like to modulate by using phase. That's what FSK is very simple to construct, and I can easily embed my distinct value of input changes, in case of phase of a carrier signal. So that's what ASK or amplitude based shift keying will suffer from noise effect. Frequency based shift keying will suffer from unwanted, unnecessary frequency generation, and phase shift keying will have an advantage like distinct amount of input amplitude changes can be easily phase changed by the carrier. So that's the advantage, like why FSK is so much useful in case of a digital communication system. Okay, so I'll be going for the next slide, so which will tell you how exactly ASK, FSK are different from AM and FM, and how we can modulate PSK. Okay, let us observe how exactly it is. Okay, let us see. This is a comparison between ASK, FSK and PSK. No doubt here the data or whatever the input is there, it is a digital signal. Okay, digital message signal it is. Okay, so you can observe here there is a input amplitude 1 and 0, right? See here it is 0, it is 1 volt. Okay, so my input is always either 1 or 0. My input is always either 0 or 1, right? As of which, if I do AM modulation to this, what happens? Can anyone? If I do, this is my input and I will be taking one carrier. Okay, if I multiply the input with carrier, what happens to AM wave? So it's very simple. Whenever there is a 0 volt, you will not get any signal. Whenever there is a 1 volt, you will be getting a signal. Which signal? No doubt it's a simple carrier wave. Okay, means for 1 I will be getting a carrier wave, for 0 I will not be getting anything, because 1 multiplied by carrier wave is equal to carrier wave, 0 multiplied by carrier wave is equal to 0. So in that simple way I will be getting a ASK signal, and you can observe how does it looks like. See, for 1 I will be getting a carrier signal as it is, for 0 I will be getting a 0, there is no signal at all. For this much duration 1 I will be getting carrier signal for that much duration. So this is a beauty of how ASK is, how ASK exactly works. Okay, so what do you think, like in case of ASK I already stated that it will suffer from the noise effect. So as of which we will go for angle based modulation scheme. Okay, let us consider what happens to FSK. It's very simple here. For logic 1 I will be getting a particular frequency here. Okay, and for logic 0 I will be getting a different frequency like this. And it's very simple to do this FSK. It's very simple. Why? Because in case of logic 1 or 1 volt I will be getting a F1 frequency, you can say, right? Okay, for logic 0 I will be getting a F2 frequency. See, logic 0 I will be getting a F2 frequency. So likewise it happens. Always you see input, digital input is always zeros and ones, so as of which you will be getting F1 or either F1 or F2 frequencies. Okay, so that's a thing how FSK is done. Okay, now we will see the concept of how phase modulation happens. Okay, you can observe here. Yes, for logic 1 what exactly happening? For logic 1 carrier will come as it is, you can observe here. For logic 1 carrier is coming as it is. Okay, now logic 0, whenever I am transition, see, whenever my transaction is happening from logic 1 to logic 0, I will be getting a 180 degree phase shift. See here, 180 degree phase shift here. See, actually this signal has to continue like this, but it has taken 180 degree out of phase like this. Okay, so it will continue up to another transition happens. See here, so this is another transition happening here from logic 0 to logic 1. So till that my signal continues, and whenever it is transiting from 0 to 1 I am getting 180 degree phase shift here. So this is how exactly FSK works. Usually my input here is binary, like 0 and 1 only. It may be like quaternary, like different input, different types of line codings are possible. So here right now I am having binary line code, like simple 0 and 1. So for that reason I can say this type of PSK as BPSK or binary phase shift keying. Okay, so our syllabus actually starts like this: binary phase shift keying, means with this how to generate this signal, what is the other aspects of this signal. Okay, so that's what, like after knowing AM and FM, so how exactly ASK is, only thing I am changing my input signal. So as of which, as input is changed from analog to digital, I will be getting a ASK here, and an input changing for analog to digital, I may get FSK here, because my input is digital. And even I can do FSK like phase shift keying for a digital input. Okay, so this shift keying, are you clear about, like keying means on off, shifting means my shifting amplitude, frequency or a phase. So these are all the things. Okay, so next I'll be introducing the digital communication syllabus, like random processes and noise. So you can observe here there are different random processes are there. Like before that, like what exactly you supposed to aware about, just a second. So random processes, like you may be clear that there are different types of random processes, like stationary random process, wide sense stationary random process, ergodic random process. All these things you supposed to understand. So as a part of digital communication syllabus. Okay, Next, apart from that, we can even understand mean, different statistical parameters like mean, correlation, covariance, all those things. There are some meaning why we supposed to understand all those things. So we will have that in a next upcoming videos. Okay. So after that, we will be having a certain sort of noise analysis. Okay. In this noise analysis, we can understand the concept of how do we represent the noise in a mathematical form, like quadrature component, in phase component, or even by using how orthogonal representation of a noise. Okay, orthogonal components I can use like more than 2-3 different dimensional noise representation, that is also there as a part of syllabus. So next, digital modulation scheme 1. So in this complete unit, we will be understanding like how to generate, how to receive, and how do I make a state space representation for that modulated signal, and even how can we calculate the probability of error for different modulation schemes. So please make sure that what we will be understanding, like how to generate the signal, how to generate the modulation signal, how to receive the modulated signal, and how do we make the probability of error calculation for a particular modulation scheme, and what will be the constellation diagram for the particular modulation scheme. Okay, what are all the different modulation schemes we will be understanding? It's very simple: BPSK, QPSK, MRA PSK, and in next unit, like what will be QAM, or you can say that as a QASK or MFSK, or even minimum shift keying. Okay, MRA, actually MFSK means MRA, MPSK means MRA PSK, MRA FSK, like that. Okay, apart from that, in this unit we will even cover the concept of orthogonal frequency division multiplexing. Okay, what exactly OFDM? It is a next version for this FDM technology, so wherein all the frequencies are orthogonal to each other, so that they will not collide each other and there will not be any interference between them. So that is the advantage of FDM. Okay, next we will be understanding the spread spectrum. I already stated that the spread spectrum is having many advantages like low probability of interception, jamming concept, security and noise immunity. So all these are very important concepts, especially for the unique applications like military applications, navigation applications, all those things. So because they provide very good security and jamming concept, and even we can have the low probability communication. That's very interesting concept actually. So we will address all those things, and we will be understanding in this unit like how to generate the PN sequence, right? Why PN sequence are useful, and how do we make different spread spectrum modulation techniques like DSSS, FHSS, and even hybrid type of spread spectrum is also there. Apart from that, how do we get the CDMA advantage? How do we get the CDMA advantage out of DSSS, direct sequence spread spectrum communication? And apart from that, we will be understanding how to generate the PN sequences. Okay. So after this, another 2 units are like information theory and coding, and last unit is different coding mechanism. Okay. So now, which books we supposed to refer? So you can refer like Top, Schilling and Sahab, or even Bipilati you can refer. So these are all the textbooks actually. These are all the other reference books: A.B. Carlson, Bernard, Wayne, Tomasi, Simon Akin, you know it well, right? Signals and systems. And if you would like to go through any NPTEL videos, so you can go through this. And I wish like everyone should make aware of all these blocks before we start a digital communication subject. Sorry, this is giving some problem here. Okay, just a second. I'll be taking this in the corner. Okay, so this is a digital communication block diagram. So we must be aware about all these concepts of all these blocks of digital communication block diagram. Actually, it's supposed to be covered in a principle of communication system subject, or a analog communication subject, you can say anything. Okay, so wherein you can even understand that which are all the blocks are necessary, compulsory. So here it is listed, and which are all the blocks are optional, compulsory blocks you can understand. You see here. So whatever the this dashed lines are there, dashed line blocks, cross line blocks are there, they are all optional, and these solid rectangles are there, they are all for compulsory. Okay, so that's what the thing. So before you start, you're supposed to be aware of all these blocks, right? Example, some of the blocks are already aware, like format means line format, data formats. Okay, all those things. Okay, fine. So this is what the introduction to digital communication and even the prerequisite for the digital communication. Okay, thank you, dear student, dear friends. So if you wish to ask any doubt related to this prerequisite, you are most welcome, and we will look forward for the digital communication concepts. Thank you for your patient listening. See you. Bye.